Based on images previously drawn, find the exact values of the following. Alright, I'll do the hard ones. Oh, hold on. I got more on my sleeve. There you go. So tired. And it turns out, just with that right there, you can do the rest. You don't even have to flip through your book anymore. Because tangent is sine over cosine. So, what's radical 2 over 2 over radical 2 over 2? 1. So what's the tangent of pi over 4? 1. How nice. And then, what's the relationship between pi over 3 and pi over 6? So this was a Sims game. Pi over 3 was one of the characters. Pi over 6 is another. This is a horrible analogy. I just like The Sims. And it's a relationship status. It would say that they are. Well, pi over 3 is 1 degrees. And pi over 6 is 1 degrees. So what is 60 plus 30? Which means that 60 and 90, I'm sorry, 30 and 60 are complementary angles, which means their radians equivalents are also complementary. So the sine of one is equal to the cosine of the other. So if the cosine of pi over 6 is radical 3 over 2, then what's the sine of pi over 3? Radical 3 over 2. Awesome. And the sine of pi over 6, which equals a half, is equal to the cosine of pi over 3, because the complementary function to sine is cosine. The complementary angle to pi over 6 is pi over 3. So these two are the same. Alright, so since tangent is just sine over cosine, what's the tangent to pi over 3? Careful. Sine over cosine. Yep, square root of 3, because the 2's would just cancel. So if you flip and multiply, you get radical 3. But for tangent of pi over 6, so what is 1 over square root of 3 rationalized? Square root of 3 over 3. Well, guess what? Since we have all this good stuff, and let's let all students take calculus, we can start to build, or we can draw actually what is called the unit circle. But before we get to that, let's do a couple more. Sine of 3 pi over 4. What quadrant is 3 pi over 4 in? Yeah. Second quadrant. So this is 3 pi over 4. Sine is what there? Positive or negative? Positive. Okay. So what is the reference angle for 3 pi over 4? In radians? Pi over 4. Okay. So the sine of a pi over 4 is going to equal the sine of 3 pi over 4, because quadrant 1 and 2 sine is positive. So what is the sine of 3 pi over 4? Over 2. I use blue. Very good. So remember, on the unit circle, sine is the y-coordinate. So notice at pi over 4 and 3 pi over 4, they have the same height above the x-axis. So the sine of pi over 4 is the same as sine of 3 pi over 4, because they have the same height up. Good. How about cosine of 2 pi over 3? What quadrant is 2 pi over 3 in? Second. There's 2 pi over 3. By asking for the cosine, the coordinates of the point, is that the x-coordinate or the y-coordinate? X-coordinate. So comparing it to the corresponding one in the first quadrant, since we're in quadrant 2 for 2 pi over 3, is it going to be the same value, or is it going to be the negative of that value? The negative of the value. So what's that reference angle for 2 pi over 3? In terms of radians? Pi over 3. So what's the cosine of pi over 3? Flashback. What's the cosine of pi over 3? A half. So what's the cosine of 2 pi over 3? Negative 1/2. Next one. Tangent of 11 pi over 6. What quadrant is 11 pi over 6? Quadrant is 11 pi over 6 in? Fourth quadrant. This right here is 11 pi over 6. Tangent is what in that quadrant? Negative. Only cosine is positive. All right, what is the reference angle to 11 pi over 6? In terms of radians? Pi over 6. So comparing it to pi over 6, according to all students take calculus, if we knew the tangent of pi over 6, would it be the same or the negative of the tangent of 11 pi over 6? The negative. So what is the tangent of 11 pi over 6. I'm sorry, what is the tangent of pi over 6? We'll start there. Radical 3 over 3. Again, flashback. So, the tangent of 11 pi over 6 would be negative radical 3 over 3. So we're doing a combination of your reference angles and your all students take calculus. Because all students take calculus, everyone knows this.